Okay, so this is a question from 5.3, as it says up here at the top, 5.3. And this is the quiz question from 5.3. So what's the formula for 5.3? I gave you that formula. Didn't we just do one of these last time? Just one, huh? So S equals R bracket 1 plus little r over n to the nt minus 1 all over r over n, like that, huh? That was, can you read that okay? My r's look like my n's, sorry. R over n, okay. So there we go. So there's the formula, and let's plug in the stuff. It says payments of 900, that's R. R is the payments. So that'd be 900. 6 months. So 6 months, what does that mean? What do we do with the 6 months? What's the N? 2? 2 times a year, right? If you're making payments every 6 months, you're making 2 payments a year. Remember, N in all these formulas, all these financial formulas, is number of compoundings or number of times per year. So N is going to be 2 times a year if you're doing it every 6 months. If you're doing it every 3 months, N would be 4, right? 4 times a year. 7%, so that means R is 0.07. So let's put that stuff in. 1 plus 0.07 over 2 to the 2 times, and then 8 years. 2 times 8 minus 1 over R 0.07 over 2. There we go. That's what we got to type into our calculator. Is that good on that? Remember, I showed you how to type that in on your calculator last time. Want me to do that one more time? Just to help make that easier. You guys have your graphing calculator with you? We'll be using that. So let's keep moving. So yeah, so I would just do all that on my graphing calculator. Let me write the answer. Well, it was A. So the answer comes out 18,873.93. If you have any trouble with that in your calculator, I'd be glad to help. Yeah.
You need to switch it.
Oh, thank you. I always forget which screen I'm on. Yeah, if you have any trouble with that, come see me. I mean, like after class. It takes 10 seconds. You know, it's just a super quick thing. Right after class, just grab me, 10 seconds. I'll be able to help you with the graphing calculator. 2 sections, I hope. And this first one is future value. What that means, it's like saving for retirement. We're going to make, what an annuity is a series of payments. An annuity is a series of payments. Payments to your own account. So in other words, you're going to like saving for retirement. So it's like saving for retirement or college, or when people save for their kids' college education. Anyway, so let's just do retirement. So it's like, what do? You start putting money in the bank for retirement, and it builds up. And at the end, you have a big pile, right? That's the idea, anyway. So that's what that would be an annuity. So what is it? How's an annuity different than like the last section where we just like put money? The last section, you just put a chunk of money in the bank one time only, not regular payments. Just one time only. What's it going to be at the end of 10 years? Compound interest, right? See the difference? Annuity, every month you're putting money in the bank and it's growing with interest. That's this section. So this section is an annuity, series of payments every month or every week or every year or whatever, putting money in the bank and it growing to be a big pile at the end. The last section we just finished, 5.2, compound interest, that was just making one deposit. And then how much is it going to be in 10 years? See the difference? This is payments, regular, consistent payments into an account that build up over time. All right, so that's an annuity. So you recognize it on the next test if they say, well, annuity, ordinary annuity. So when you see that, let's write the formula. S equals R. You don't have to memorize the formula. You can put it on your 3x5 card for the next test. Math Excel gives a little different version of the formula. I don't want you to be confused. If you look at theirs, they use an I and do something a little different. Anyway, here we go. R is 12,500, so that's R is the payment. So notice this person is putting 12,500 in the bank semi-annually. What does that mean? Twice a year. So N is to remember. N is always the number. N is always the number of compoundings. Here, let me write again. Well, no, we're good. We're rolling. 12,500. R, the interest rate is 7%, so 0.07 over 2. Hey, is this the same problem that we just did? Almost exact, except for the number on the outside. Otherwise, it's the same, huh? N times T, and the number of years is, no, 8 years is the same too. Man, it's similar. Over 0.07 over 2. Yeah, so can you crank that in your calculator? I'll try it too. So try doing it the easy way I told you about. Just start on the inside, keeping enter every time. But remember, when you divide by the denominator, put parentheses around the 0.07 over 2. I'm getting $262,137.87. Y'all getting that?
Yeah.
Good.
So round to $1 though.
Oh, they say dollar? Oh, you're right. So we'll round it to 262,138, won't we? Thanks for that. There we go. Questions? We okay? All right. Okay, so now, fine. So let's go with the same formula. Again, we're talking about an ordinary. Well, they don't say annuity, do they? But they said 7 payments. So as soon as they say payments, you go, oh, annuity. Grab the annuity formula. So S equals R. What is it? 1 plus R over N to the NT minus 1 over R over N. Like that. So we grab that formula again and find the size of each of 7 payments made at the end of each year at 9% rate into a 9% rate sinking fund. That's the same thing. It's an annuity. You're just sinking money into a big building up account, which produces, is that 69,000? Yeah. Yeah, not 690. 60, I put a comma in there. 69,000 at the end of 7 years. So the 69,000, that goes right here, doesn't it? That's the amount of money it produces in the end. That's what the pile is in the end. That makes sense? Oh, now that's the pile at the end. And they're asking me for the payments. So remember, the R is the payments. Let me write that in for you. And the S is the pile at the end. So the S is the pile at the end. The R is the payments. So they're asking me for the payments. They're telling me the pile at the end is 69,000. Okay. The interest rate is 9%. The N, the number, N is the number of compoundings per year, right? Number of compoundings per year. That's always what N is in all these financial formulas. So how many times per year are we doing stuff with our money?
Once.
Just once. Yeah, end of each year, N is 1. Makes sense? They're not doing it twice a year. They're not doing 4 times a year. They're making the payment once a year. Once a year. N is 1. And we're doing it for 7 years. T is 7 years. 7 payments at the end of 7 years. So R over N, 0.09 over 1. There it is. Everybody good with that? Now let me come up here and clean that up a little bit. It's going to be 69,000 equals R. Now 0.09 over 1, what's 0.09 over 1? Just 0.09, right? Dividing by 1 doesn't do anything. So let me get rid of that part. And 7 times 1 is just 7. So there we go. Cleaned it up a little bit. Oh, I lost the minus 1, didn't I? Is that what you were saying? Yeah, thanks. I forgot the minus 1 in the formula. Thank you. Did I do that in the video too? Ooh. Trouble. Yes, minus 1. Here we go, like that. Good? All right, now, I'm trying to solve for R, right? They're asking me what the payment size is. How do I solve that equation for R? Got to divide by that whole big chunk, don't I? That whole big chunk has to be, oh, here go my notes, has to be divided by. So that whole big chunk divided by. So let's do that. Let's divide by that whole 1 plus 0.09 to the 7 minus 1 over 0.09. What do you do to one side? You have no choice but to the other. 1 plus 0.09 to the 7th minus 1 over 0.09. And you, I'll put brackets like that. You've got to divide by that whole thing. Cancels, and that'll put R alone, won't it? How about that? That'll put R alone for us. So can you do that on your calculator? Let me help you. Do that on your calculator. All right, so everybody see what we got to do. Let me actually write, let me get that on a fresh screen, and let me write out some steps, and then I'll calculate it with you. So it's going to be 69,000 divided by, what is it? 1 plus 0.09 to the 7 minus 1 over 0.09. I think that's right? Yeah. Okay, so there's what we need to do, right? Let me just write out what I would do on the calculator. So guys, what I'm going to do is I'm going to start off right here again. I can make everything work from there. Let me show you. This will make it way, rather than typing that whole massive thing in with parentheses over parentheses over parentheses and all that, and trying to count your parentheses and accidentally messing up by 1. Just start right there and just go 1 plus 0.09, hit equals, or enter. It's enter, actually, isn't it? 1 plus 0.09, hit enter. And then go to the 7th power. Enter. Minus 1. Enter. Divided by 0.09. Enter. At that point, I've done the whole denominator. You with me how that will lead you through the whole denominator? Then what do? Then you type 69,000 divided by, and you hit the answer key. Do you know where that is? It's it's at the bottom of the, you got to hit second answer. It's right at the bottom of the calculator. So you're saying 69,000 divided by the previous answer, and hit enter. And you'll have it. Does that make sense? Let's try it. Oh, I just turned that off. Oh, back on. Let's try it on the graphic calculator. Okay, so those are the steps to go through. So type those steps out. Let me do it on the graphic. So 1 plus 0.09, hit enter. To the power of 7, hit enter. Minus 1, hit enter. Divided by 0.09, hit enter. At that point, I have on my screen 9.200434, that whole thing. That's the whole entire denominator, right? That's the whole denominator. Now, that's this entire denominator. And now you just go 69,000 divided by, and you've got to go, where's the, a little more room here. There it is. There, you see the answer key at the bottom? It's above the negative, at least on the TI-84. It's above the negative. Hit second and the negative key. So answer, and it puts answer in your screen. Now, it's a different key on Casio Natural Display or whatever calculator you have. But there you got an answer key somewhere if you have a nicer calculator. Second answer, hit enter. There it is. So it comes out to be 7,499 point. I don't know if they want. Would it round to 65 cents? 65. 7,499.65. I don't know if they want the nearest dollar or what they want on that. I'll go back and see. Let's see. They want nearest cent. Yeah. So then that would be the answer. You guys getting that okay? On the calculator? Is that coming out? questions I can answer? Is that all good? All is well? All right, I will move ahead if you're good with it. Okay, so same formula. You know, we're making sinking fund is an annuity. It's just a fancy word for annuity. You're sinking money into a fund that's growing and growing. So here we go again. S is R, 1 plus R over N to the NT minus 1 over R over N. Forget that minus 1 sometimes. Okay. Yeah, Math Excel also presents this formula a little differently. Anyway, their way's fine too. My way's a little easier for something else. Anyway, whatever. Come see me if you have confusion on that. So here we go. So find the interest rate. So let's go. 17,424 to be accumulated in 4 years. Quarterly payments of $975. Get the idea? We're putting $975 into the account, sinking it into the account quarterly, every 3 months, right? 4 times a year. So N is 4, isn't it? We're making 4 payments a year. N is 4, quarterly. N is 4. So 4 times a year, we're making an R, a payment, of $975. This is my S. It's the pile at the end of the 4 years. The pile is the 17,424. So we're trying to pile up 17,424. So let's give it a try. We don't know the little r, though. We don't know the interest rate. Let's plug in what we got, though. So the S is the 17,424 equals R, which is 975, times 1 plus, I don't know little r. N is 4. To the 4 times T. T is also 4. 4 years. Minus 1 all over R, which I don't know, over 4. Everybody good to there? Right, so the T is 4 and N is 4. Quarterly, so N is 4. 4 years, so T is also 4. Now, that looks awful, doesn't it? I mean, how are we going to solve for R? Are you kidding me? R's in 2 places, 2 ugly places, there and there. How are you going to get those alone? How are you going to isolate that R? Graphing calculator. No way by hand. No. Do you realize how terrible that thing would be? Let me show you. Don't write this down. But maybe you're not feeling the weight of horribleness of that equation and the great need of the graphing calculator. If you tried to do this by hand, do you realize what this piece would be? This would be 1 plus R over 4 to the 16th power. What are you going to do with that? You might say, oh, just do the 1/16. Well, yeah, that's easy to say. But you got this other R down here. What can you do with him? Terrible. Horrible. Graphing by hand, I don't even know. I probably couldn't do it by hand. So graphing calculator. Graphing calculator. So go ahead and type this into your graphing calculator. Here, let's clean up. Let me show you how we use the graphing calculator. What do I mean? We'll make the left side. Let me get it straight here. Okay, the left side, 17,424. That'll be Y1. Or Y2, whatever. One side's Y1, the other side's Y2. The other side, 975. Put in the X on the graphing calculator, that'll be the X. X over 4, this is 16 minus 1 over X over 4. So this time we are going to have to type it all in.
You can change the X divided by 4 to because I remember seeing the video to times 4 over X. The bottom one.
Oh yeah, did I show that?
Yeah, you did.
Yeah, that's another. Would that be easier? That might be easier.
It's easier to type in.
Yeah, probably. Yeah, good idea. Good idea. Yeah, let me show that trick again then. Yeah. So yeah, when the denominator, whenever you divide by a fraction, did you know that's the same thing as multiplying by the upside down? Yeah, so that's probably easier. Let's just do it that way. Whenever you divide by a fraction, why? I don't want that just to be something Miss Heron says. Well, you remember what 10 12 12ths or whatever. That's kind of a weird one. What about 2/3 divided by 4/7? Whatever. Remember how to divide fractions from earlier? Remember what you do? You flip the one in the right, make it 7/4, and change to times. Remember that? See how we flipped that fraction? Well, that's the same thing as like 2/3 over 4/7, right? Isn't 2/3 divided by 4/7 sideways the same as that? Doesn't that mean divide? Am I losing you? Doesn't this mean 2/3 divided by 4/7? And which is that? This is just sideways, 2/3 divided by 4/7. This is vertical, 2/3 divided by 4/7. They're both 2/3 divided by 4/7. And what's the rule? You flip the 4/7, right? Remember, when you divide on the right, you flip the one on the right. So that's why the rule is when you have a denominator, you just grab him and flip him and make it times. See, that's what this says, huh? So I'm just proving to you that that is the rule. You don't have to do that. I'm just showing you it didn't come out of nowhere. It's something you already know. When you have division of a fraction, you flip it, right? Because dividing is upside down multiplying, isn't it? If I say 10 divided by 2, that's the same thing as 10 times a half, isn't it? Half of 10 is 5. 10 divided by 2 is 5. Dividing is upside down multiplying, isn't it? So therefore, when you're dividing by r over 4, it would be easier to bring it up, flip it, and multiply by 4 over r. That way you don't have a big old dividing thing. So let's do that. Let's get rid of this. Like that. And then I'll put over here on the right 4, and the r is x. Right? I'm putting in the variable on the graphing calculator is x. They just use x for everything, the graphing calculator. So in the spot of r, in the place of r, I'm putting x. So there is what I'm going to type in for y2. Thanks for letting me know that. It's helpful when you guys watch those YouTubes and you tell me because I forget sometimes the best way to do these things. Put that in for y2. So put it in for y1, y2, then graph it and go second, calc, and choose intersect. Because you want to know where they're equal, where they intersect, and hit enter, enter, enter 3 times. Have we done this before? Have we done intersect in here? We did a little bit, huh? Okay. So y1's the left side. y2's the right side. Graph the thing. Second calc, intersect, enter, enter, enter. All right, if you've got that written down, you guys got that copy down? I'll do it on the graphing calculator with you. Let me write that out even more clearly. So y1 is going to equal, what's y1 again? 17,424. And y2 is going to equal 975. Double parenthesis. 1 plus x over 4. Close the parenthesis to the 16th power. Minus 1, close the parenthesis. Times 4 over x. Right? Is everybody seeing that? See where I had that double parenthesis? Because see here, if I color code, it might be easier. Here's the inner set of parentheses. Here's the outer set of parentheses. Do you see how it's parentheses within parentheses? Everybody see that? They go together like that. Right? Because that, why? Why do they go together like? Because that's what we had here. See how the brackets, it's like the brackets are kind of like the outer parentheses. Brackets, parentheses are all the same thing. They're just different style. The same meaning. And then the inner. Everybody see how we have outer and inner? Right? Everybody seeing that? So I put it in like that. Now, hit graph. Back over here. So you hit graph, and then if you cannot see an intersection, hit second table. It's above graph. Hit second table, and what it'll tell you is it'll tell you the values it'll say, well, here's where y is. It'll show you the xy table that the calculator's making. It'll say, well, here's the values, and then you go, oh, look at that y1. It's up at 17,000. If my y max is not above that, I'm not going to see anything of that equation. Do you see the deal? It's telling you where the graph is. So the y1, of course it's, remember that's what y1 equals, 17,424, of course. Right, and the other one's big too. The other one's at 1950, and the next one is 3860. And the y1's always 17,424. So then you go back, okay. Then you go to window, so now let's go back to window and hit the window button and make the y max big enough to cover 17,424. Like make it 20,000, let's say. Just whatever. Something that'll be big enough. 20,000. Make the y min, I guess, 0. So it's all about the y max. Y max has to cover those y values. So second table shows you that. Then go back to your window. Make your y min 0, your y max like 20,000. And then hit graph again. And I'll show you what I'm getting. So I'm getting that. It's kind of weird looking. At least I got something on my screen. It's hard to tell what's really going on there, isn't it? Y'all with me? You guys getting something like that? My x is negative 10 to positive 10. That's not the right x. I'm going to need to change it in a minute. But first off, I'm just saying, if you want to get my picture, my y min is 0, my max is 20,000. So let me help for just tried to graph it. It's still looking kind of crazy. This is why these are hard. So using technology is kind of tricky, isn't it? Graphic calculator is not simple. This is real life computers. People are like, oh, computers do everything. We don't need to study math anymore. That's not true. You got to be the smart operator. Calculators, computers, they don't know nothing, to use bad English. They don't know anything. And you've got to be the smart one. They're just fast. That's all they are. They don't know anything about anything. You've got to tell them and direct them to it. So what am I directing weirdly or badly or without a good thought? What is x? You got to remember, what is x? Real world. Here's x. Well, x is right here. Yeah, what's it taking the place of? Yeah, r. R is what? A rate, a percentage. R is something like 10%, or I don't know what we're trying to find it, 8% or something. Meaning R is super small. So X is super small. I don't want X to go negative 10 to positive 10 or even 0 to 10. X is something between 0 and 1 at most. 1 would be 100%, right? It's a decimal. Remember, X is taking the role of R. R is a decimal. It's a percentage converted to a decimal. So that then I go, oh, no wonder I'm getting nothing on my screen. So I go back to my graphing calculator, and I go, oh, okay. So then I say x, I'm going to make my x min 0, and my x max is just going to be like, it's not going to be 50%. What are these interest rates at most? I'll make it 0.20. 0 to 0.2. It's not going to be over 20%. I'm just going to make it 0 to 0.2. That make sense? Graph. There it is. Clear intersection. Right there. See the problem? We had to, calculator was just going, okay, I'll do whatever you want me to do. And just cranking the numbers fast. Computers and calculators are not smart. You've got to be the smart one. They're just fast. So operating technology requires intelligence. You got to know what's going on in the word problem. So I changed so everybody getting that graph okay now? I made my x go from 0 to 0.20. My x min is 0. My x max is 0.20. Now we get a good graph. Now hit second calc. Go down to what did I hit? Let's try it again. having a lot of trouble today. Second calc, go down to intersect, hit enter, enter, enter. Boom. There it finally is. We've got an answer. So I'm getting X, which is the interest rate, of 0.05821189. I don't know how many places. You got to move it 2 places to make it a percentage, right? So I'm getting 5.8211%. How many? How close do they want the answer? 2 decimal places. So 5.82%. That's the interest rate. We finally found it. But using that technology requires a lot of thinking and skill. I'm glad to help you more with that. I better move on. We spent a long time on that problem. 5.82%. That good on that? Questions I can answer? So grab me after. If you're still not getting it, you're having trouble, grab me after 10 seconds probably. Okay, so now they've been talking ordinary annuity. Now they're going to say annuity due. Annuity due. That means the payments at the start of each period. So the only difference, let me just write, problems 1 through 6 were ordinary annuity, which means payments at end of each period. So ordinarily, an ordinary annuity, you make the payments at the end of each period. That'd be like saying, I'm going to save up for retirement at the end of every year. I'm going to put $1,000 in the bank. Or that wouldn't go very far, huh? But anyway, whatever. Right? So that would be an ordinary annuity at the end of every period. Annuity due, if they say annuity due, I'm going to give you a different formula basically. Annuity due, you're making the payments at the start. So that'd be at the start of every month instead of the end of every month. It's a little bit different formula. It's not much different. It's not really a big deal. The annuity due formula. Annuity due, where is my annuity due formula? Oh, it's right here. Is S equals R bracket. It looks almost the same. 1 plus R over N. Instead of just to the NT, it's NT plus 1. And then this is R over N. And then another minus 1 outside the fraction. Here's the only 2 new pieces. I'll circle them for you. This is new, and this is new. Otherwise, it's the same as the other formula. It's just a little more complex. It's got those 2 new pieces. So it's just like the last formula was, the ordinary annuity formula, but it's got those 2 new pieces. So there it is. You just use it, plug it in, crank it out. Want to try this one? So find the future value of a 15-year annuity due with payments and an annual compound interest rate of 6.8%. So here we go. The payments, $15,000. And it's going to be 1 plus R. The interest rate is 6.8, so that would be 0.068 when you move the decimal back 2 places. Over N. What's N? What's the number of compoundings per year on this one?
1.
Yeah, 1, because it says annual, once a year. So to the N, which is 1, times T, 15 years, minus 1, or plus 1 up there, all minus 1 over 0.068 over 1, and then the other minus. There's a lot of minus 1s, huh? Well, there's 2 minus 1s. See all that? That last minus 1 is, for the entire, after you have the whole fraction done. Right, so there's the 2 new pieces, this piece and this piece. So type it all into your calculator. I would do piece by piece. What's this power? If you figure out, I would just figure that power out in my head. What's 1 times 15 plus 1? 16. That's just 16th power, right? So I would just type in 1 plus 0.068, enter, to the power of 16, enter, minus 1, enter, divided by 0.068, enter, minus 1, enter. You read that? That little Joseri thing's in the way, huh? So just type it all into your graphing calculator. So 1 plus 0.068, enter, to the power of 16, enter, minus 1, enter, divided by 0.068, enter, minus 1, enter, and last step, times 15,000, enter. And you should get an answer. That's a good answer. I'm getting 396,000. Write it up here. 390,419.49. You guys getting that? Okay. That's how big the pile will be at the end of that process. All right, questions on that one? I better move. Take a look at that one. Give you a second. Try to figure out if is this ordinary? Annuity. Okay, so an ordinary annuity, payments at the end. Annuity due, payments due at the start. So which one is this?
Ordinary.
Yeah. End of each period, huh? So it's ordinary annuity. So you would use the ordinary annuity formula, which was the first one I gave you, right? The one that's less complex. R over N to the NT minus 1 over R over N. Like that. So I'm not going to do the rest of the problem, if that's okay. I'm just helping you to identify. So if they say the payments are at the end of the period, that's ordinary. That's ordinarily what they do. But every now and then they'll give you one with payments due at the start of the periods. That's annuity due. Is that good? I'll move on from that. So is Gilberto, is he putting the money in at the beginning or end of each year? The periods are years here, right? Her birthday, 1 year. Every year he puts 1,100 in. Is Gilberto doing it at the beginning or end of every year?
The beginning.
The beginning, the day she was born. He slammed down $1,100, right? The day she was born. He didn't fool around. $1,100 at the bank. I know what he's doing down at the bank on the day his wife gave birth, but whatever. But $1,100 in the bank. Maybe he just did it by remote. The day she was born. So, but here's the trick. He also did it on the last day. Her 13th birthday, which is the end of the last period. So what you do is you just do, basically he did it at the start of each period, he did it at the start of each year, let's say. The start of each year, so that means I'm going to do annuity due, right? Because that's not ordinary. And that at the end, you just take the answer. At the end, you take the answer and you add the last $1,100 he put in. Because that last $1,100, he just did it on her 13th birthday, and they want to know right then at the end of the day how much. So that last $1,100 is just straight added. It hasn't got any interest at all. He just put it in that last day. Do you get it? So basically he did 12 years of putting in money and growing and piling up because of interest and stuff. And then that last payment, he just put it in the bank. So you just add that last $1,100 separately. Does that make sense? It's not part of the normal annuity. Because the way an annuity works is you put in money, it grows for a year. Put in more money, it grows even bigger for a year. Put in more money, grows for a year, right? Putting in money at the start of each period. That's an annuity due. Start of each period. But then that last payment, there's no period for it, right? He didn't let it sit for a year. So it's not a normal, we can't factor it into the normal stuff. We just say it's an extra $1,100 out at the end. That's the trick. So you basically do 12 years. You let T be 12 years of money growing, because that's how long the money grew for, right? It grew for 12 years. Wait, no, that's not right. It grew for 13 years. Yeah, that's confusing. Because when you turn 13, you have lived for 13 years. 13 years have gone by. So it's 13 years of growth, and then the extra $1,100 at the end. That's still true. That last $1,100 is the 14th payment, actually. Do you realize? Because he made a payment at age 0, all the way through age 13. He made 14 payments, technically. That's what was tricking me for a second. Yeah, so 13 years of growth plus 14th payment. There we go. So, can I just go ... You just got to do the annuity due formula, which is 1 plus R over N to the NT plus 1 minus 1 over R over N minus 1. And then at the end, add $1,100. That's what you got to do. And the T is 13 years. And the N is once per year. He's just doing it once a year. And the rest is normal. Is that good on that? So I'll let you copy that. Y'all's got that copied down? Well, it'll be on way, and we'll be done. Okay, so man deposited $14,000 at the beginning. What kind of annuity is this? Annuity due. The beginning, it's an annuity due. It's due at the beginning. So S equals R, 1 plus R over N to the NT plus 1 minus 1 over R over N minus 1. Okay, for 12 years, T is 12, 4% for the rate, and each year, so N is 1, once per year. So you plug all that in, 14,000 is the R, and then the second part is a compound interest question. Here, let me just whip it out for you real quick. So in other words, the first part of the question, you just put in the 14,000, 1 plus R, the interest rate's 0.4 over N is 1. To the NT, T is 12 years, plus 1, all that's minus 1, over 0.04 over 1, minus 1. Crank all that out. I'll just do that super quick here. So that would be 1.04, 13th power, minus 1, divided by 0.04, minus 1. Times 14, 1, 2, 3. Okay, so I just got an answer. This is 1 down here. I just got the answer. What did I get? 218,007. That's not the final answer yet. It's halfway. 775.73. So at the end of the 12 years, his money has piled up to be 218,775.73. Then what does he do? He then puts that total pile on deposit, 5% for another 11 years. So the second part is not an annuity. He's not making regular payments anymore. He's just taking that whole lump sum and just putting it in the bank to sit and grow for the next, whatever, 11 years. So for that second part, part 2, it's just A equals P 1 plus R over N to the NT. Does that make sense? It's just growing. It's not payments. It's not an annuity. It's not regular payments, is it? So you just put in, there's the 218's the principal he puts in. The interest rate is what, 5%? So that's 0.05. It's semi-annually, so N is 2 for 11 years. T is 11. And crank that out, and you'll get your final answer. All right. Woo, that was a lot.